Welcome to Lesson 2, the applications of basic linear graphs. The learning intention for today is that students will understand the role of the gradient and the y-intercept variables in a problem. You'll know you're successful if you can clearly calculate the values of the gradient and the y-intercept and explain their roles in the assigned problems. First of all, let's look at the role of the y-intercept and the gradient. The y-intercept, we know, that occurs when x equals 0. So that often represents the initial or original value of a variable. It's what it is at the start, if we're talking about time, which we often are. And again, it is a fixed value, like a fixed cost, an initial cost, an initial distance. It's something that does not change. The gradient, which we know is rise over run, the gradient represents the rate of change of the y variable with respect to x. So as x changes, how does y change as well? We're going to introduce a key sentence here, which should look very familiar, because this is the exact same thing that we did in our unit on data. The key sentence is the y variable, whatever that is, distance or cost or revenue, whatever it might be, increases or decreases by a certain number of units as the x variable increases by run units. So there's a few things to just match up here. In particular, rise and run. So those are values coming directly from our gradient. And just a quick refresher here, if you don't remember, how do we know when we use the word increase and when we use the word decrease? I'll let you give that a try. If you don't remember, please go back to your notes from the first topic. Now have a chance to go through worked example 1 and come back and see me again when you're finished. Next up, let's look at determining the equation of a line. So in general, we know we have y equals mx plus c, and that's split into two parts. There's the part that's going to be changing, and the part that's constant or staying the same. The constant term, that is, as we talked about just a couple of minutes ago, that is the fixed term, the fixed value, that is the y-intercept, that is c. And the changing part is the part that depends on x, whatever our x variable might be. So that's mx. That's the rate of change. As x increases or decreases, y increases or decreases as well, and that change comes from this part here. When we're answering questions that are worded questions with linear graphs, it's really important that we use the correct units for the variable. And this goes back as well to that key sentence you just wrote down. If I'm talking about kilometers, I should say the distance increases by 7 kilometers. I need to use my units and use them correctly. And an interesting little thing here is often the gradient in itself is something useful. So to figure out what units the gradient is measured in, we use this little formula here. It's the units for the y variable divided by the units for the x variable. One very common example that you'll see of this is if x is the time in seconds and y is distance in meters. So we're dealing with time and distance and time. The units for the gradient will be our units of y, which is distance, over our units of x, which is time. So meters over second, or meters per second, which course, is speed. And we'll come back and we'll see some examples where it's very relevant and very useful to be able to analyze the gradient and use its units as well. Have a go now at worked example number 2. Work your way through that video, and then come back again once you're finished. The second part of this lesson has a slightly different learning intention. It's very simple, and really it is review. Students will understand the difference between interpolation and extrapolation. You'll know you're successful if you can successfully determine, or correctly determine, when to interpolate and when to extrapolate, and you know the difference between one and the other. Very simply, and again, this goes back to what we did with data management very early on in the year. Interpolation is making a prediction where the value you're predicting for lies within the known range of values. So if I have data, if I have information between 1 and 10, any prediction I make within that range of 1 to 10 is interpolation. Extrapolation, on the other hand, exterior is outside, making predictions above or below the known range of values. So above 10 or below 1, for example. Have a go now at the final worked example. Watch the video and come back here for a final wrap-up. Let's think about whether you've been successful here. You've got the 2 success criteria from this lesson in front of you. Reflect on that, think about that, and then you can start to try some of those questions to see if you have been successful, if you understand what this unit, what this lesson has been talking about. Thank you.